Hello everyone. Today we are going to calculate problems on efficiency. Let me just tell you what is efficiency. So efficiency is equals to output by input. Efficiency is equals to output by input. What is input? Input is output plus losses. Output plus losses. So how many types of losses are there? There are two types of losses. Total losses is equals to iron loss. Losses are denoted by W. If it is iron loss, you will denote it as WI. Iron loss are also called as fixed loss, or they are also called as core loss. One more loss is copper loss. I'll denote it as WCU. Let me just quickly rewrite the formula. So it will become efficiency is equals to output by input is output plus losses, right? So output plus losses. So how many types of losses are there? Two types. So output by output plus iron loss plus copper loss. Iron loss plus copper loss. So this is the way how you calculate losses, right? Sorry, efficiency. So in efficiency, you are going to calculate output, you are going to calculate input, you are going to calculate total losses. So the formula for total losses, you can rewrite it as iron loss plus x square into copper loss. Iron loss into x square plus copper loss. So what is this x? For example, if he is asking you to find the efficiency at full load, if is efficiency at full load, efficiency at full load. So what is the value of x? X will be full load means 100 by 100, right? So it would be 1. If he is asking you to calculate efficiency at half load, so what you will write? X is equals to 50 by 100. That would give you 1 by 2. And if you are going to calculate efficiency at 25% load, efficiency at 25% load, then X value will be 25 by 100. It would be 1 by 4. If you are going to calculate efficiency at 75% load, then the value of X will be 75 by 100. That will give you 3 by 4. So 15 threes are 15 fours are like that. Now let us quickly solve one problem. So solution. Okay, let me just tell you what is the question given. So in the question, he'll give you how much kVA. Okay, how much kVA and what are the losses, right? And he'll ask you to find out the what do you say, efficiency at half load or full load. So the question will be given as he'll be giving you in a 50 kVA or 20 kVA single phase transformer has iron loss and copper loss, and the power factor will be given. Right. If the power factor, for example, if he is giving you as a unity power factor, then you will take the power factor value as 1. If he is giving you power factor at 0.8, then you can take it like that. So let me just write the question first. So the question given is, he has given in a 5 kVA, in a 5 kVA, 5 kVA, 100 by 200 volt, 50 hertz, okay, transformer, single phase transformer gave following results. Okay, so for some results are given, right? So following results. So what he has given, iron loss he has given as iron loss is equal to 90 watts, and he has given copper loss is equal to 110 watts, and he's asking you to find efficiency at full load, find efficiency at full load at 0.8 power factor. So like this question he has given. So instead of 0.8, he can give you unity power factor also. If he is giving you unity power factor, then you need to take the power factor value as 1. So how will you solve this problem? Initially, what is the formula for efficiency? It is output by input, right? So output by input, right? So what will be the X value? X value would be 100 by 100. That would be 1, right? So how you are going to calculate? Let me just do it. Now he is writing it as efficiency at full load. So first I'll calculate output. Observe carefully, right? Output at full load, output at full load is equal to, the formula is X into kVA into power factor. What is the formula? X into kVA into power factor. What is the value of X? As it is full load, the value of X is 1. And what is kVA given? I think it's given as 5 kVA, right? So 5 into, what is the power factor given? 0.8. So it will be how much? 0.8 into 5. 0, 4. So it would be 40. Right? So how much ever you're getting? Okay. How much ever you're getting? Let me just find it. Okay. So what he is asking more, so you observe the question properly. If you see the question, he is asking you to find the efficiency at what? He is asking you to find the efficiency at full load, right? So 0.8 into how much? 5, no? Okay. So that would give you 4 kilowatts. It is given as 4 kilowatts. Right. Next is, he'll be giving you input at full load is equals to, what is the formula for input? Output plus losses. Output plus losses. So total losses is equal to iron loss plus X square into copper loss. So if I'm not wrong, iron loss is given in 90 watts. Okay, sometimes what he'll do is he'll give this losses in kilowatts, right? Then you need not, divide by 1000 there. See how we are going to solve. So one is given as 90 and another is given as 110. Let me just write. So iron loss is 90 plus 1 square into 110. So 110 plus 90 is how much? It is 200, right? So 200 watts. So now I have to divide by 1000, 200 by 1000. Why I am dividing? Because they are given in watts. For example, in order to confuse what he'll do is he'll give this losses in kilowatt. Then you need not divide by 1000. You have to remember that. So 2 by 10 is 0.2 kilowatts. Now I got everything. So efficiency at full load is equal to output by input. What is output? What is output you got? You got 4. What is input you got? Output plus losses, no. So 4 plus 0.2. So that would be 4 by 4.2. So how much is 4 by 4.2? It is 0.952. So if I want percentage efficiency, it would be 95.2%. So thank you. Similarly, you can solve for half load, 25% load, 75% load.